Hello everyone, welcome to CodeGuide, and today we'll discuss the topic RAG summarization strategies. We'll discuss why it's important, why do we need it, what the different types of strategies involved, the advantages and disadvantages of each strategy, the use cases and summary. So let's start. Now, if you see RAG summarization strategies, RAG will start with RAG. Now, RAG stands for Retrieval-Augmented Generation. It combines the retriever, that is, it fetches relevant documents, and with a generator like GPT to produce more accurate and factual output. Now, according to the RAG summarization definition, in a RAG system, summarization involves retrieving chunks of context from documents and using an LLM to generate a concise summary. So, whenever in a RAG architecture, we pass any query to the chatbot we are working with, it retrieves the context related to the question, and then the LLM summarizes this document or the context which we have retrieved from the vector database, and then it gives a concise summary. It summarizes the whole context. If five relevant documents are retrieved from the vector database, then instead of giving five documents directly to the user, it generates the concise summary and generates a human-like response so that the user can understand. So that is the RAG summarization. Now, why it's needed? The documents can be long, structured, or spread across multiple sources. So whenever we try to retrieve some document from the vector database related to the user query, it can be long and unstructured also, and it can be spread across multiple sources. So if the documents retrieved are much more, we cannot give the document in one go to the user as an answer. We need to do some summarization task so that the answer can be generated properly and accurately, and it should, and if the user is asking the answer in very short form or in a short what we can say data, then at that point of time we need to do summarization using the LLM for giving the user answer. Now, as we know, LLMs have context token limit. So generally, when we are summarizing or whenever we retrieve from context, now if the retrieval technique has given 10 documents or 20 documents, and there is some limit for feeding the data in one go towards the LLM. So 20 documents cannot be passed in one go towards the LLM. It will show an error at the input tokens error, and which is not good. So we need to do some summarization technique for feeding the retrieved document to the LLM. Now, helps in question answering for document understanding and chatbot, right? So retriever wherever the RAG architecture is involved and question answering use cases, document understanding is involved. At that point of time, we need the RAG summarization strategy. We can also define it as a summarization that taking multiple retrieved documents and creating a concise, meaningful summary using an LLM. But when the documents are too large or too many, we need strategies to handle them sufficiently. And why it's needed? We have discussed all these points here. And LLM, like the GPT, if you are comparing, it has limited context window. Like, for example, 8K tokens, 16K tokens. That is the limit for context window. And sometimes the document may be too long to fit in one prompt in one go. So at that point of time, we need to do some summarization, and we have different summarization strategies for that. And we need to break the document and process them smartly. If the documents are too large or too long fit in one prompt, then we need to break them and process them smartly. Now, the need to break and process, that is where we have the strategy, that is the RAG summarization strategy. Now, the problem of chunking. To summarize that document, you must split the data into chunks. First of all, if the data is too big to fit to the LLM, we need to split the data into chunks and then apply summarization logic to each chunk or the whole set. We can also have different strategies here. We can, the document which I have retrieved, we can split those chunks and then summarize it. And we also have different strategies where we can summarize each chunk and then pass the finalists, then pass each summarized chunk to the LLM, and then LLM will create another summarization. So we have multiple strategies. Now, in case of the problem of chunking, we often split long documents into chunks, but not all chunks are equally important, right? Chunks may lose meaning out of context, and summarizing chunks poorly leads to a bad final summary, and that's where we have different strategies. Now, different strategies exist to balance performance, accuracy, and token efficiency. So all three parameters are very important while considering the chunking strategy or the summary strategy. Now, moving on, we have the overview of summarization strategies. We have four most common summarization methods used in RAG system. First one is the stuff, then is the map reduce, refine, and map rewrite. Now, each strategy has trade-off in terms of speed, quality, and cost. So at the point of use case, whenever speed is needed, we will use that strategy. Where quality is needed, according to that, we will select one, and according to the cost also, we can select the summarization strategy. Now, we'll see the overview. Now, in case of stuff, all content fits in one prompt. Whenever we have small retrieved chunks or small retrieved document, and the document size is very small, we can pass the all content which is put in one prompt. Now it works best when content is short or small, right? Whenever we have short content to summarize, then we will fit instead of creating more chunks, we will fill that all data, all documents in one go, and that is the step one. Now in case of map reduce, we summarize chunks. Now if I have created 5 chunks or I have retrieved 5 chunks or what we can say. I have retrieved, suppose, a long document and I have created 5 chunks of that document, of that long format document. Then, after creating 5 chunks, I will summarize each chunk separately. And after summarizing each chunk, I will pass the output of each chunk into the final summary again to the LLM. Now, this type of technique, that is the strategy we use when we want scalability. And third one is the refined one. Now, we build up the summary iteratively. Whenever you want accuracy plus refinement, so at that point of time, we need use refine. We have the map re-rank, which rank best and summary. So ranking technique is involved, and we use or we it works best when we want best possible answer. This is the overview of summarization strategy. We'll start with the stuff. Now, in consideration of stuff, it is simple and direct, as they have discussed earlier. Now, how it works? All chunks are stuck together into a single prompt. Whatever chunks we have created from the documents which we have retrieved, they are stuck together into single prompt. So, and then we summarize the chunk by the LLM. Now, it is the what we can say advantages are it is fast and simple and no intermediate steps are there. So, and disadvantage is that it only works with small input and it may cause token overload or poor summarization. As we are feeding all the data in one go, so sometimes if the document is too bit too large as expected and can cause a token overload or poor summarization also. Now you can also think like giving the whole article to a friend and asking them to summarize it all at once. So that can be an example. And now it is best for short document. Next one is the map reduce strategy. Now in case of it working, map means summarizing each chunk independently. Now, for example, we have created 5 chunks and we'll summarize each chunk separately. And after summarizing each chunk, the answer produced from the each chunk will be passed again to the LLM to reduce the combined summaries to get a final result. And that is the map reduce strategy. Now, its advantage are it handles large documents and it breaks tasks into manageable parts. It is also parallelizable, so you can also remember this advantage. Now, cons are it is more expensive as multiple LLM calls are involved. As we are summarizing each chunk using the LLM, suppose 5 chunks are there, and we have summarized each chunk. So we are calling the 5 times LLM. And again, for the final summarizing of all the collective summarization of each chunk, we call the LLM again for the final summary. So if we are creating 5 chunks, then we are calling the LLM 6 times. So it can be more expensive as compared to the stuff. Now it might lose coherence between the chunks. That is, it might lose the deep connection, or what we can say is the relativity, or the what we can say connection between the two chunks. If the retrieved documents of each chunk has connectivity between the one and second chunk, and if you are summarizing it separately, the connection loss will be there, and proper meaning will not be retrieved. Case of the it may lose the deep connection between the. Now, for example, like summarizing each chapter of a book. Okay, we have multiple chapters in a book. Now we are summarizing each chapter separately, and then summarizing all the chapter summaries. So this is the best example for map reduce strategy. Now it was inspired by big data processing. So whenever the data involved is large, then we need to scale this, and for that we use the map reduce strategy. Now next is the refine. We'll see how it works. Now first of all, it is an iterative process. So first of all, if you have 5 chunks created, and for first chunk we will summarize the chunk first chunk, and whatever summary will be created from the first chunk will be passed while creating the summary of the second chunk. So the connection which was lost earlier in the map reduce between the first and second chunk is what we can say it is reduced directly, as we are passing the first summary to the second chunk, and for creating the summary of the second chunk, as the first summary is also available, then proper connections are developed between the first and second chunk. And after creating the summary of second chunk, we pass that second chunk summary towards the creating of the while creating the third chunk summary. So in this way, at the last point where the if you have 5 chunks, so fifth summary will be the overall combination of all the summaries of the each 5 chunks. So there will be good connection, and long term information will be written here as we have understood all the context. So this will generally it keeps improving summary. So as per the definition, we have that it summarizes the first chunk and go through each subsequent chunk and refine the summary by adding new context. So this is the way of working we have seen earlier how it works. Now it's good for progressive understanding, right? Because as we go one by one for each chunk, by passing each previous chunk summary towards the next summary, so we get the progressive understanding, and it maintains a single evolving summary. And as we are not creating different summaries at once for all each chunk, we are maintaining a single, and it is evolving. We are adding some each chunk data towards the previous summary, so and creating more concise summary. Now, the disadvantage are it is prone to drift or repetition as we are passing multiple chunks, previous created chunks to the newer chunk, towards the newer summary. So it can be prone to drift or repetition, and it is sensitive to chunk order. Now, if the chunk order is not maintained, or now suppose we have in order for sequential, like first, second, third, fourth, fifth, five chunks are in sequential order, then it is good. But if the sequential order is not there, and they are randomly, what we can say, introduced, and at that point of time it is sensitive to the chunk order. Now it is idle when newer context may change understanding. So this is the use case and overall working of the refined strategy. Now we have the map rewrite strategy. Or the one more example for the refined can be like writing a rough summary. Okay, and after writing the rough summary, then updating it every time you read something new. So at the last, we'll get a precise and accurate, or what we can say is progressive understanding of overall summary. Now next is map rewrite strategy. Now how it works. It generates a summary or response per chunk. For example, we have five chunks and create a summary for five chunks, and then it scores each summary by relevance, and it returns the highest ranked one according to the query given by the user. So we can say that create a summary for each chunk, five chunks, five summaries, and LLM ranks which one best answers the query. So this is the map rank, and it shows are that it is useful for question answering and actual based stuff, and it helps pick most relevant response. Now we have also the disadvantage that it doesn't combine information as five different chunks are created, and we don't create the final summary. We just compare and rank the different summaries, so it doesn't combine information and not a full summary, just best option. Now it is best for selecting best answer versus the summarizing whole. Whenever we need, what we can say is the best answer according to regarding to the all summaries created, and at that point of time we leave the map rank strategy. Now it is like asking five people to answer a question, then picking the first one. So this is the map rank. Now in comparison of the stuff map reduce, refine, and map rank, we for the handling of large document stuff cannot do that, while as other three can do that. Now the quality is medium for stuff as it handles large big document in one go. So quality is medium, and for the other map reduce, we have high and medium high for refine also, and map rank is focused as we are doing the ranking strategy. Now speed, in case of the speed, it is fast as we are not calling the LLM multiple times, so it has fast speed. And map reduce as we are calling the LLM multiple times for five chunks, we need to call the LLM six times, so it can be slow. While as in refine, it is moderate. We cannot say that fast also, so moderate. And map rank is compared fast as towards the both groups, the map reduce and refine. Now use case, we have stuff for short text summarization as we discussed earlier, and map reduce is generally used for long form document summary, right? And for refine, we have the progressive summarization, and for map rank, best answer select. So this is the comparison. Now, why these strategies matter in RAG? In RAG pipeline, retrieval brings chunks from the vector database. We know whenever we retrieve document for a user query, it will bring chunks from the vector database. Now, summarization strategies control how these chunks are processed. Whenever these chunks are brought from the vector database, they can be very big in size. So we need to process those chunks, and there comes the summarization strategies. As we cannot pass these big chunks in one go to the LLM model because we have the context window limit, and for that we need to create the or use the different summarization strategies. Now, strategy affects the response quality. If you are using the summarization strategies, then the response quality will be good. The token cost might increase depending on the what we can say the different strategies involved, and model efficiency will be higher if you are using the summarized strategy. Now you will see a real world use case, that is the legal document assistant. Now whenever a user app summarize the science section of this, 80-page contract. So user is asking a question where we have to summarize the science section of the 80-page contract. So for that purpose, we likely to use the map reduce for higher accuracy or refine for dynamic understanding, and stuff would fail due to the input size. As the input size is very large, 80-page contract, so stuff would naturally fail as it will hit the context window limit. Now choosing the right strategy is equal to better user experience. We should use the right strategy considering to our question and considering to the context window of our LLM, and also the cost, while accuracy, how much we want. Multiple factors are involved while choosing the right strategy. Now the strategy selection guide is choose based on document length, right? What is the document length we are trying to summarize? LLM context window, as we discussed, the speed versus the cost trade-off. We want the speed for the, what we can say, getting summarization part, or we want the cost. For means we need to compare what is more good for us or for our personal use case. Is it speed or cost? Then the last one is the need for completeness or the focus. How good should be the answer done by the LLM or the chatbot we are working with. Now, a good rack system may combine multiple strategies depending on the use case. If you are want to build a more accurate or answer compared to the user query, then we need to build we need to build or combine multiple strategies depending on the use case. Now, benefits of structured summarization. Now, it improves comprehension as we discussed, answer accuracy, latency control, and token efficiency. Now, the structured summarization helps in chatbot, assistant, search interfaces, meeting summarizers, etc. So these are the multiple use cases where structured summarization helps. And in most of the Gen AI use cases, we use chatbot, and at that point of time, or the meeting summarizers, at the point of time, we need the summarization strategy. Now we'll do the summary of overall topics we discussed in this presentation. The track summarization helps distill large content into usable answers, and the four core strategies, as we discussed, are stuff, map reduce, refine, and map rewrite. The strategy choice impact performance, cost, and quality. Very true, and important for document based AI assistant and question answering systems. So hope you guys understood. Now we'll move towards the implementation part. Now we'll start with the implementation part. First, we will use the AI keys. So from google.colab, import user data on AI key equal to user data dot get OpenAI. We'll bring the keys into our environment. So import with dot environment, right? And OpenAI API key. Yeah. Key. Now we'll install the different components like the LangChain. We'll install LangChain and LangChain community, and OpenAI. We need 5 PDF for uploading the document. Okay. Now run this. We'll start. Now we'll import the summarize chain. So for that we'll say from LangChain dot chain dot summarize, as we need to summarize. So dot summarize import load summarize chain, right? From LangChain dot LLM import OpenAI. Okay. Then we'll mention LLM is equal to OpenAI. Now we'll mention the summary chain. Summary chain equal to load summarize chain. Load summarize chain, and we'll mention the LLM is LLM equal to LLM. Okay. We have created the summary chain. Now we need to get the document loader. So from LangChain dot document loader import py PDF loader. Okay. Now for our implementation part, I have included the attention is all in your paper, the research paper, and we'll work on this paper. So I will copy the path. Okay, loader equal to py PDF loader, and we'll copy our path here. Now we'll load it. So doc is equal to loader dot load. I will see how it looks. You can see in case of the document by PDF or we have loaded. So we have document as a metadata, we have metadata as well as different data is available here. We have the page content. So this is our data now. We have converted this data, our original data which was in PDF in a format where the LLM can accept it. So this is the way we can do that. We have to get our metadata and we also have the page content. This is the page content. Now we'll see the length of our doc. How many are there? Doc. So it shows we have 11. Now we'll pass this document to our summary chain and see if it works or not. Summary chain and doc. We have got an error that this model's maximum context length is 4097 tokens. However, you have requested 8517 tokens. So our document size is very much large to fill it in one go to do the LLM. So we need some summarization strategy. So for that, now for the stuff part, it is default. It is by default. So we'll say here stuff. We have it by default. Now second one was our map reduce, right? So we'll see map reduce now. Map reduce. Map ready. For that we need to install tick token. Tick token. As we will be counting the number of tokens here. So for that we need the tick token library. Okay. Now in summary chain equal to load summarize chain and we have introduced LLM equal to LLM and chain tag. Now we'll see map reduce. Map reduce. Okay. So the error was that I had included this instead of underscore. So we got the error solved. Now we'll pass our document summary chain. Previously, we are getting error, right? Because the error previously we were getting. Now we'll see how it is working. Now we'll see, as you have seen previously, we are getting error for this document, which we are not mentioned the chain tab. It was taking stuff as default. But if we are passing the map review, we are able to pass the document in one go. And we are creating some, we are creating different chunks here. And after creating chunks, we are creating summary of each chunk. And after creating summary of each chunk we are passing the whole summary of each chunk towards the final LLM and the final summary is created. So this is the map reduce. Now we'll move towards the refine one. Now for the using the summary refine one, you'll just see how it is done. Summary chain and load summary chain LLM equal to LLM and we'll pass the chain type at refine and we'll pass a new variable here output equal to summary chain and we'll pass dot one. Okay. Dot one pass the dot put of output fetch. Okay. In this way, we can use the refine, map reduce, and stuff, and we have the different strategies according to our use cases. If the documents are small, we can use we can go with the stuff. When we have much larger document, we can go and we can it is doing parallel processing in case of map reduce, while in case of refine, it can also handle large document, but less information loss compared to the map reduce, and it is a sequential process. Sequential process. So hope you guys understood this implementation part, and if you understood, please like and subscribe our video channel, and we'll see you in the next session. Till then, bye.